Have you ever wondered how the DNA of an entire people can connect us to some of the most pivotal moments in history? Greek DNA is more than just a genetic code. It's a time capsule that carries the legacy of ancient civilizations, legendary myths, and human adaptability. Think about it. Greece is often called the cradle of Western civilization. It's the birthplace of democracy, philosophy, and epic tales that have inspired the world for centuries. But beneath the surface of its rich cultural heritage lies another fascinating story, one told through the genes of its people. From the ancient Minoans and Mycenaeans to the influence of empires like Persia and Rome, Greek DNA reflects a history of migration, resilience, and survival. In today's video, we'll explore why Greek DNA is so unique and how it reveals secrets about our shared past. You'll learn about its ancient origins, the genetic impact of invasions, and the unique traits that make Greeks one of the most intriguing populations in the world. So, what makes Greek DNA so fascinating? Let's dive in. Greece has always been a land of significance. As the crossroads of Europe, Asia, and Africa, it has been a meeting point for civilizations, trade, and cultures for thousands of years. But its importance isn't just historical or cultural, it's also genetic. Greek DNA tells a story of connections, adaptations, and resilience that has shaped not only the people of Greece, but the course of human history. The geographic position of Greece has made it a genetic melting pot. Ancient travelers, traders, and conquerors left their marks, blending their DNA with the indigenous populations. Over time, this created a genetic profile that reflects a unique mix of influences from across the Mediterranean and beyond. But what's remarkable is that, despite these layers of external influence, modern Greeks share a striking genetic continuity with their ancient ancestors. Why does this matter? Because understanding Greek DNA isn't just about unlocking the secrets of one population. It's about piecing together the broader puzzle of human history. The genetic traits and variations found in Greeks offer clues about ancient migrations, the spread of cultures, and even how humans adapt to specific environments. Moreover, Greek DNA plays a crucial role in modern science. From its contributions to understanding diseases to its relevance in studying longevity and human adaptability, the genetics of the Greek people continue to provide invaluable insights. In short, studying Greek DNA helps us understand not only the past but also the present and future of humanity. Next, let's journey back in time to explore the ancient origins of Greek DNA and how it connects us to some of the earliest civilizations in human history. To truly understand why Greek DNA is so fascinating, we need to go back tens of thousands of years to the first humans who set foot on the land we now call Greece. Archaeological evidence suggests that early humans arrived in the region during the Paleolithic period, drawn by its rich resources and temperate climate. These hunter-gatherers laid the foundation for what would later become one of the world's most influential civilizations. Fast forward to the Neolithic period around 7000 BCE, when the first farmers arrived. These early agricultural communities likely migrated from Anatolia, bringing with them the skills to cultivate crops and domesticate animals. Genetic studies confirm this connection, showing clear links between the DNA of early Greek settlers and populations in modern-day Turkey and the Balkans. This migration marked a pivotal moment in Greek history, as it set the stage for the development of more complex societies. One of the most intriguing chapters in the story of Greek DNA comes from the Bronze Age, with the rise of the Minoan and Mycenaean civilizations. The Minoans, based on the island of Crete, were among the first advanced civilizations in Europe. Genetic studies of ancient Minoan remains have revealed surprising links to populations in the Near East, such as the Levant, as well as connections to mainland Greek populations. The Mycenaeans, who followed the Minoans, are often considered the direct ancestors of classical Greek civilization. Their DNA shows a mix of local ancestry and influences from the steppe regions, likely linked to the spread of Indo-European languages. What's remarkable is that modern Greeks share significant genetic continuity with both the Minoans and the Mycenaeans, suggesting that the core population of Greece has remained largely stable over millennia. Adding to the intrigue are the surprising genetic connections between ancient Greeks and populations as far away as the Caucasus and North Africa. These links hint at complex trade networks, migrations, and cultural exchanges that shaped the genetic landscape of Greece long before recorded history. The ancient origins of Greek DNA aren't just a story of migrations. They're a testament to the resilience and adaptability of the people who lived in this region. Despite centuries of invasions and upheavals, the genetic legacy of these early populations continues to live on in modern Greeks. Next, we'll explore how these invasions and empires, from the Persians to the Ottomans, added new layers to the genetic story of Greece. The genetic story of Greece would not be complete without understanding the influence of invasions and empires. Over the centuries, Greece's location at the crossroads of Europe, Asia, and Africa made it a target for conquest and a hub for cultural and genetic exchange. Each wave of invaders left its mark on the DNA of the Greek people, adding new chapters to their genetic story. One of the earliest and most famous encounters was with the Persian Empire during the 5th century BCE. While the Persian Wars are remembered as a clash of civilizations, trade and cultural exchanges between Greece and Persia were ongoing. Although the Persian invasions didn't result in long-term rule, genetic studies suggest subtle contributions to Greek DNA from populations in the Near East, likely due to trade, intermarriage, and migration over centuries. When Greece became part of the Roman Empire in 146 BCE, a new era of genetic and cultural blending began. The Romans brought people from across their vast empire to Greece, soldiers, merchants, and settlers from regions as far away as North Africa and the Middle East. These migrations introduced new genetic variations into the Greek population. The transition from the Roman Empire to the Byzantine Empire didn't sever these connections. Under Byzantine rule, Greece became a center of commerce and learning, further cementing its role as a genetic melting pot. Despite these influences, the genetic core of the Greek population remained remarkably stable, reflecting a resilience that endured through centuries of external rule. The Ottoman Empire ruled Greece for nearly 400 years, leaving a profound impact on its culture, language, and genetics. During this time, there was significant migration between Greece and other parts of the Ottoman Empire, including Anatolia and the Balkans. Genetic studies have identified traces of these exchanges, with some Greek populations showing markers linked to Turkish and Balkan ancestry. However, what's fascinating is how distinctively Greek DNA remained, even during this prolonged period of foreign domination. This speaks to the strength of Greek identity, which persisted through cultural, linguistic, and genetic resilience. What makes the Greek genetic story so remarkable is how these influences, from the Persians to the Ottomans, blended into an already rich genetic tapestry without erasing its distinctiveness. The core DNA of the Greek people, rooted in ancient Minoan and Mycenaean ancestry, has endured through millennia of invasions and migrations. This genetic continuity raises an important question. How has Greek DNA maintained its unique identity despite so much external influence? The answer lies in the resilience of the Greek people, their cultural traditions, and their ability to adapt while preserving their heritage. Next, we'll look at some of the unique genetic traits found in Greeks today, traits that reflect both their ancient roots and their adaptability to the Mediterranean environment. Greek DNA is not only fascinating for its history but also for the unique genetic traits that have evolved over thousands of years. These traits reflect a deep connection to the Mediterranean environment and reveal how Greeks have adapted to their surroundings. One of the most famous aspects of Greek culture is the Mediterranean diet, which has been celebrated for its health benefits and association with longevity. But did you know that Greek DNA might play a role in how well the population benefits from this diet? Studies suggest that Greeks carry genetic markers that enhance their ability to metabolize healthy fats found in olive oil, nuts, and fish, key components of the Mediterranean diet. These adaptations, combined with the diet's rich nutrients, help explain why certain Greek populations, like those on the island of Ikaria, are known for their exceptional longevity. While Greek DNA offers many advantages, it also carries certain genetic risks. For example, Greeks have a higher prevalence of thalassemia, a genetic blood disorder that affects hemoglobin production. This mutation likely evolved as a defense against malaria, a disease that was once common in the Mediterranean region. Another example is familial hypercholesterolemia, a genetic condition that causes high cholesterol levels. While rare, Its presence in Greek populations has provided valuable insights into cardiovascular research and treatment. Many Greeks share physical characteristics that are linked to their DNA and the Mediterranean climate. Features like olive skin tones and dark hair are influenced by genetic markers that help protect against the intense Mediterranean sun. These traits are not just aesthetic, they reflect a long history of adaptation to the environment. Greek DNA also reveals a remarkable genetic resilience. Despite centuries of migrations and invasions, the genetic diversity within Greek populations has remained high, contributing to their adaptability. This diversity has helped Greeks thrive in challenging environments, from the rugged mountains to the sun-soaked islands. What's most fascinating is how these traits combine to create a distinct genetic identity that reflects both ancient roots and modern adaptations. Greek DNA isn't just about preserving the past. It's about thriving in the present and building a foundation for the future. But while much of Greek DNA is well understood, there are still hidden mysteries waiting to be uncovered. In the next section, we'll dive into the unanswered questions and surprising discoveries that make Greek genetics even more intriguing. Greek DNA is filled with stories that science has yet to fully unravel. Despite the extensive research into its ancient origins and unique traits, there are still mysteries hidden within the genetic code of the Greek people. Mysteries that challenge our understanding of history and humanity. Recent genetic studies have uncovered traces of prehistoric migrations in Greek DNA that go beyond the well-documented influences of Anatolian farmers and steppe herders. Some of these genetic markers point to connections with populations in North Africa and the Near East that predate recorded history. One of the most intriguing findings is evidence of genetic links between ancient Greeks and populations along the Nile River. These markers suggest that trade routes or shared cultural practices may have facilitated gene flow between these regions thousands of years ago. Could these connections hint at a deeper relationship between the civilizations of the Mediterranean and those of Africa? Another mystery involves the presence of ghost populations in Greek DNA. These are genetic signatures from groups that no longer exist or remain unidentified. Some researchers believe these markers could belong to ancient peoples who lived in the Aegean region before the rise of the Minoans and Mycenaeans. One theory suggests that these populations may have been seafaring traders who left behind no physical records but contributed to the genetic makeup of the Greek people. Others speculate that these ghost populations might hold the key to understanding the origins of certain Greek cultural practices and myths. Greek DNA also plays a central role in one of the biggest questions in human history: the spread of Indo-European languages. Genetic studies suggest that the Mycenaeans, who spoke an early form of Greek, were part of a larger migration of Indo-European-speaking peoples from the Eurasian steppe. However, not all aspects of this migration are well understood. For instance, how did the Indo-European influence integrate with the earlier Minoan civilization, which spoke a non-Indo-European language? And why does Greek DNA show such strong continuity with its ancient past, despite these linguistic and cultural shifts? These unanswered questions remind us that genetics is an ongoing journey of discovery. Greek DNA isn't just a record of the past. It's a gateway to understanding migrations, cultural exchanges, and human adaptability on a global scale. As science advances, new tools and technologies may help solve these puzzles. But for now, Greek DNA continues to surprise us, offering tantalizing clues about forgotten migrations and lost civilizations. In the next section, we'll explore how these discoveries intersect with Greek history and mythology, providing fresh perspectives on some of the most iconic stories from the ancient world. Greek mythology is filled with epic tales of gods, heroes, and legendary civilizations. From the labyrinth of the Minotaur to the Trojan War, these stories have captivated imaginations for centuries. But could Greek DNA hold clues that validate elements of these myths? As scientists study the genetics of ancient and modern Greeks, they're uncovering links between history, myth, and reality. The Minoans, Europe's first advanced civilization, are at the center of the legend of the labyrinth and the Minotaur. Archaeological and genetic evidence suggest that the Minoans were an advanced seafaring people with genetic ties to the Near East, the Balkans, and even North Africa. These connections align with their reputation as master traders who influenced cultures across the Mediterranean. The study of Minoan DNA has also revealed how this civilization thrived on Crete for centuries before its sudden decline, possibly linked to a volcanic eruption or invasion. Could this genetic research one day confirm whether the Minoans inspired the myth of Atlantis? The Mycenaeans, the heroes of the Trojan War as told in Homer's Iliad, left behind not only archaeological treasures but also a genetic legacy. DNA studies have shown that modern Greeks share strong genetic ties to the Mycenaeans, who were a mix of local Neolithic farmers and steppe migrants. This continuity suggests that the people who built palaces at Mycenae and fought in legendary battles are direct ancestors of today's Greeks. What's even more intriguing is how genetic studies are helping historians refine their understanding of the Mycenaean world. For example, research into their trade networks has revealed connections to Egypt, Anatolia, and Mesopotamia, providing context for the far-reaching alliances and rivalries described in ancient myths. Alexander the Great's conquests spread Greek culture and influence from Egypt to India, creating a vast Hellenistic world. Genetic studies are now exploring how these campaigns may have impacted the DNA of populations far beyond Greece. Evidence of Greek genetic markers has been found in regions like Central Asia, hinting at the lasting legacy of Greek expansion. Greek DNA also provides insights into the intersection of history and mythology. While myths like those of Zeus or Poseidon may never be proven, the genetic links between ancient civilizations and modern Greeks show how real events and migrations may have inspired these timeless stories. The study of Greek DNA doesn't just validate elements of history, it brings new depth to the myths and legends that define Greek identity. By combining genetic evidence with archaeological and historical records, we're uncovering a more complete picture of the ancient world. Next, we'll explore how Greek DNA is shaping the future of science, medicine, and global health, proving that its significance extends far beyond the past. Greek DNA isn't just a window into the past. It's a tool that's helping scientists address some of the biggest challenges of today and tomorrow. From advancing medical research to preserving genetic diversity, studying Greek DNA has far-reaching implications for science, health, and humanity as a whole. Greek populations have unique genetic traits that are proving invaluable for medical research. For instance, the high prevalence of thalassemia in Greece has helped scientists better understand this blood disorder, leading to improved treatments worldwide. Similarly, studies on familial hypercholesterolemia, a genetic condition that causes high cholesterol levels, have contributed to breakthroughs in managing cardiovascular diseases. Greek DNA is also helping researchers explore the genetic factors behind longevity. The island of Ikaria, known as the Island of Long Life, has a population with one of the highest life expectancies in the world. By studying their genetic markers, scientists are uncovering insights into how genes, diet, and lifestyle interact to promote healthy aging. These findings could one day revolutionize how we approach healthcare and aging on a global scale. Greece's diverse landscapes, from sun-drenched islands to rugged mountains, have shaped the genetic adaptations of its people. By studying Greek DNA, researchers are gaining a better understanding of how humans adapt to different environments. This research has implications for tackling challenges like climate change, as it sheds light on how populations can survive and thrive in extreme conditions. As the world becomes increasingly interconnected, preserving genetic diversity is more important than ever. Greek DNA, with its unique blend of ancient continuity and external influences, serves as a reminder of how diverse populations contribute to human resilience. By documenting and studying Greek genetics, scientists are ensuring that this rich genetic heritage is preserved for future generations. Greek scientists and institutions are playing a leading role in genetic research, with projects like the Greek Genome Project working to map the DNA of local populations. These initiatives are not only advancing global science but also ensuring that Greece's genetic heritage is studied ethically and benefits the people it represents. Ultimately, the study of Greek DNA is about more than just Greece. It's about understanding the broader human story and using that knowledge to improve health and well-being for all. The genetic insights gained from Greek populations are contributing to personalized medicine, rare disease research, and our understanding of how genetics shapes our lives. Greek DNA isn't just a relic of the past. It's a living resource that's shaping the future of science, medicine, and humanity itself. Next, we'll bring everything together in a powerful conclusion, reflecting on the enduring legacy of Greek DNA and its importance to us all. Greek DNA is more than just a record of ancient migrations and civilizations. It's a living testament to resilience, adaptability, and the enduring spirit of a people. From its deep roots in the Minoans and Mycenaeans to its unique traits shaped by the Mediterranean environment, Greek DNA tells a story that spans tens of thousands of years. It's a story of survival through invasions, empires, and upheavals, while still maintaining a connection to its ancient past. What makes Greek DNA so fascinating isn't just its history. It's how it bridges the past, present, and future. It validates elements of mythology, deepens our understanding of human evolution, and provides critical insights into modern science and medicine. The study of Greek genetics doesn't just help us understand one population. It helps us uncover the shared story of humanity itself. As science advances, Greek DNA will continue to play a vital role in solving some of the most pressing challenges we face, from improving global health to preserving the diversity that makes humanity so resilient. It's a reminder that our genes carry not just the legacy of our ancestors, but also the potential for shaping the future. So, the next time you think of Greece, remember that its DNA isn't just fascinating. It's a key to understanding the past, thriving in the present, and building a healthier, more connected future for all of us. If this journey into the mysteries of Greek DNA captivated you, make sure to like, share, and subscribe for more deep dives into the stories that connect us all. What did you find most surprising about Greek DNA? Share your thoughts in the comments. We'd love to hear from you.